Hey everybody, so we're going to interpret constants of proportionality in graphs in the little con support video. So let's get started. So here it says Clark has a budget of $12 to spend to buy nuts for a party. The three lines represent the cost of buying bags of three kinds of nuts: walnuts, pecans, or peanuts of varying weights. Okay, so the x-axis is pounds or weight. The y-axis is cost in dollars. Obviously, a steeper line, I think we can all see, is going to be a higher constant of proportionality, which basically would be what? Output over input, cost per pound. So a line that goes up faster just means that for every input, you're paying more money, right? So the cost per pound is high, right? And a line that goes more gradual means it's cheaper, right? These nuts are cheaper per pound, basically. Or that's it. That's all it means. So anytime you're looking at a graph and you're interpreting how it represents the constant proportionality, just remember that a steeper line means that the constant proportionality is higher, which means that the unit price or unit value is higher, right? Every unit is worth more. And the more gradual lines, right, that are not as steep, this means that your unit price is lower, which means that your ratio of y over x is lower, right? As x increases by 1, y increases by less, right? So basically, that's it. Your unit price would be the value of y when x is 1. So you can see there would be our representation of the unit price for peanuts. There would be our unit price for pecans, and then walnuts would be somewhere up there, wherever it lines up perfectly, okay? So that's kind of the idea. So it says, which kind of nut can Clark buy the most of with his $12? Well, which one's the cheapest? Peanuts. The one that has the lowest rate of acceleration, basically. As you increase by 1, you're only increasing the y by 4, right? So it's $4 per pound. It's way cheaper than the other two nuts. So this is definitely the one that's the cheapest. So that's the one you'd buy. Peanuts. Okay, this one says the graph shows the relationship between the length of time Ted spends knitting and the number of scarves he knits. So bottom x-axis is scarves, y-axis is hours. So one scarf, it takes how many hours, and so on and so forth. And you can see it says 1, 16, right? So that means that one scarf takes this person 16 hours to knit. Or is it knitting? I don't know. Yeah, knitting. So what does 16 mean in this situation? It means that it takes him 16 hours to knit one scarf. That's what it means. The X is scarves, the Y is hours, the X stands for the scarves, the Y stands for the hours. So this means 1, 16 in one. He can make one scarf, and it takes him 16 hours to make that one scarf. So choose one answer. Ted has to knit 16 scarves. No. Ted knits 16 centimeters. No. It takes Ted 16 hours to knit a scarf. Yes. Okay, so the next one. The three lines represent the number of hot dogs eaten by three contestants at a hot dog eating competition. Okay, L, J, and K. So this is x-axis is minutes, y-axis is hot dogs. So basically in this case, the higher slope, or the one that has the steepest line, is more hot dogs per minute, and the one that's the lowest line is the least hot dogs per minute. Well, what does that mean in concept, like in terms of an idea? The one that's the steepest line is eating the fastest, and the one that's the less steep line is eating slower. That's basically what we're talking about here. So which contestant was eating at the slowest rate? Well, the K. K's eating at the slowest rate, right? His line is going at the slowest rate. It's the least steep, and we can see the other ones are increasing at a faster rate than it. And so if you think about comparing rates, right, K is going to be slower than L or J. So contestant K. It says the graph shows the distance Kendrick walks in different lengths of time. So here we can see that it takes him 1 hour to walk 5 kilometers. So that's his rate, right? That 5 kilometers per hour. That's the speed he's walking. So how many kilometers does Kendrick walk per hour? He walks 5 kilometers per hour. How long does it take Kendrick to walk 1 kilometer? Well, if it's 5 kilometers per hour, right? So the ratio of y over x, right, is 5 over 1. Then if you flip that relationship, you're going to get the number of hours per kilometer, right? Or how long it takes him to walk 1 kilometer. So instead of 5 over 1, it's just 1 over 5. You just reciprocal that relationship. So 1 over 5 is 0.2 or whatever. So if it was divide 60 by 5, you get 12. So 12 minutes, or 0.2 hours. Okay, so this is hours, so 0.2, or you could think of it as 1/5, 1/5, same thing. And that's how you do it. All right.